Okay, great. Amit, please go ahead, introduce yourself.
So, hi Fatemeh. My name is Amit Seta. I'm
Mhm.
a researcher at the Australian National University in Canberra in Australia, and I mostly work on magnetic fields in galaxies. So, in simple terms, basically, I'm trying to understand the force which helps fridge magnets attach to fridge. How do they work on galactic scales at like extreme temperatures and extreme conditions and on extremely large scales? So that's basically my goal, and I do this via theory and numerical simulation, but also looking at lots of radio observations from radio telescopes around the world.
All right. Do you do public outreach though?
I have done some public outreach in the past, not
Yeah, because
recently.
this was a very public outreach oriented introduction. I was like, I'm going to be as simple as possible so people understand what I'm saying. No,
Yeah,
this is cool. This is a cool way of saying it.
magnetic fields are usually complicated even for people who work on magnetic fields.
Oh,
So
of course,
even I
yes. I
would
mean,
say,
they're a mess. Yeah, they mess up everything. Yeah, right.
yeah.
No, this is true.
So that's I usually when I talk to like astronomers, I usually uh, talk about a bit more details. Just saying magnetic fields is usually not very sufficient in my view.
Right. True. No, it is very true. I think in all of the fields, not only galaxies, like also stellar sciences or AGNs or
Yeah.
yeah, like many other fields.
Yeah.
So, do you want to talk a little bit about your journey as an astrophysicist? Like, how did you become an astrophysicist eventually? How did
Yeah,
you
sure.
start?
So,
And yeah, like, where was the starting point for you? Let's go from the very beginning.
so I would say the starting point was really at school levels. I come from a town in West Bengal called Belda. This is West Bengal in India. So this is the
Right.
one of the eastern states. And I was very interested in school in variety of subjects, including sciences. Like I also liked history a lot, and I also liked geography a lot.
Mm.
And my parents both are not from academia, but they were very supportive and encouraged a lot about studying. And I was very interested, so I liked various aspects of how history has gone through and what's the geography of geographical areas and also sciences and maths. So I was interested in a variety of subjects, and then
Mhm.
particularly interested in science. And so I moved to take science, and then I think high school was a bit of a game changer, I should say, because then we
Mhm.
really went into physics. Because before that, there was physics, but there was very little of it. And then when things get divided into physics, chemistry, maths, and computer science, that was very interesting. I was able to see lots of aspects of physics, and that motivated me to take physics because I really liked the going deep and how it can explain everyday phenomena and how simple experiments can tell about very deep physical concepts was very I found that very interesting and also
Like
quite
the everyday
challenging.
phenomenon, like how
Sorry.
things work. Was that the thing? Because like how is the physics syllable like in the let's say in high school because you have it in different stages, right? Like it's like the first year, second year, and then third year, and then so which were the topics that were covered early on? Did you had anything also connected to quantum mechanics, for example, like something that was fancier,
No,
astrophysics or astronomy,
no, no,
general astronomy?
no, nothing like that. In high school, I literally had like, oh, there was a bit of classical mechanics, there was a bit of EM. I think that's mostly all and optics, of
Okay,
course.
right.
So there was a bit of
Okay, optics and Newtonian mechanics then. Okay.
Newtonian mechanics, optics, and electrodynamics, or
Mhm.
electromagnetism
Right.
were three major things. I think there were some also side things, but these were three major things. And to give you a specific example of what I'm saying is like when in high school I did an experiment with pendulum was to find G, the
Oh, right.
gravitational constant. It's like
Yeah, that's
you have
something
a
that we've all done.
exactly. So simple, everybody has done it, and it's literally
Right.
like you take a stopwatch and you
Right.
keep changing the
The
length of
lamp,
the
right?
pendulum, and then
True.
you make a table of length versus time, and
Right.
then from there you find time period, and from there you find G. And it's like
Right.
amazing. I mean, this is the same gravitational force which is keeping Earth going around Sun. And I could calculate, it's like I could quantify a value. However, wrong. I mean, it is not very, I
Right.
don't think I got a very accurate answer. And I was worried why it is 9.9, not 9.8. When I'm always,
Yeah.
when I'm doing my analytical calculations, I'm usually taking it 9.8, but it came out to be way different from 9. And I was like, oh,
Okay.
wow.
Right.
So
Okay.
those kinds of things, like even a simple thing told, gave us information about very deep physics, which worked on a variety of scales, maybe.
Okay.
So that's why I got very interested in physics. And usually in India back then, I think
Right.
it's a bit prevalent now also to be fair, but back then, usually people who take science in high school were divided into two types, like either engineers or doctors.
Right.
Like people either
True.
pursued engineering or doctor, or they go for
Right.
medicine. And this is extremely popular, but I liked the engineering sides of things more, not doctor.
Mhm.
My elder brother is actually a doctor, like a medical doctor, not like me. I'm also a doctor now.
Okay. Different type of doctor. Yeah. Right.
Different type of doctor, yeah. So I never wanted to take medicine because the biology was too hard, I should say,
Mhm.
for me. And I liked the engineering aspect of it, and I gave all of this entrance exam. India works in slightly different way,
Right.
that you have this entrance exam, everybody gives an entrance exam, and then
True.
based on your rank, you are allocated some university which might be like miles away from your home, and you might get
All
2 days
right.
to even reach there. But it's basically dependent on a list which is
Mhm.
central, which is generated centrally. So I gave all of those exams, and I was also looking around, and I was slightly inclined toward computer science. But then this opportunity to study at Department of Atomic Energy, Center for Excellence in Basic Sciences, which is in Mumbai, which is very far from my
Right.
home. So Mumbai is western,
Okay.
almost western India, came up. I was given the opportunity to interview at least for a course which was integrated masters in physics.
Okay.
And
Right. So
I
you
was
chose
like,
physics. Like how did you choose between engineering and physics though?
yeah, because I was always inclined toward physics, but there are less opportunities, I should say. At least back then, there were
Okay.
less
Right.
opportunities. So
Hmm.
you give all of these exams, but most of those exams are for engineering,
Okay.
and most of the seats are for engineering, and most of the
All right.
colleges are all most of the colleges which take students from these entrance exams are for engineering courses.
Okay. Right.
There are some physics also, but they are very less, I should say.
Hmm.
And when I was given this opportunity, I was like on one of the most memorable day of my life. It was not even sure because it was just an like a possibility, but it was not even
Right.
sure.
True.
So I was not sure whether this is going to work or not. But I was so happy, and it was far from home in Mumbai. I mean, that was bittersweet, but I focused on
All
this
right.
part of it. And then when I went to give interview, I was told that in the entrance exam, my score was highest in maths. So maybe I should take maths.
Okay.
So there was another hurdle. I was like, no, 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 no. I want to
Yeah.
do it.
Right.
And the
So
interview,
many dilemmas to deal with. Yeah. Right.
yeah. And the interviewer was like, your maths course is quite high. You should take math. And I was like, no, give me an opportunity to do physics for 6 months. And if you feel like
Right.
I'm doing great, I'm happy to shift, sir.
Hmm.
And then said,
Okay.
okay, let's fine. Okay, okay, he is happy for us to filter it out later, so maybe it's okay. So the course works in a bit weird way that physics, chemistry, maths, biology, all four people are admitted, and they do first year is common for all. So I did even in my
All right.
college, though my degree was physics, I did all four subjects again with everybody. The one
Right.
who is biology major, the one who is chemistry major, the one who is physics
All
major.
right.
All of us did together. And then I was always stuck around in physics. So that's a very bumpy journey, but I landed up in physics.
I mean, honestly, the question that I have for you is that you were so hell-bent on studying and pursuing physics, and I think that requires something more than just a pendulum experiment
Sure,
only. Like,
sure,
so did you have this moment of, yeah, like physics is amazing because of this thing, or like how things work, or was it only problem solving? Because problem solving also exists in engineering courses.
sure,
Also,
sure,
like for mathematics, like mathematics is very artistic in my opinion. So you could just
sure.
pursue any of these. So like how is it that you really wanted physics among all these majors?
Sure. So the pendulum was just as an example. But I saw in my view, at least then I realized that physics is something where the framework was very interesting. So there is a framework for doing maths, right? Like if you think of an abstract,
Right,
it's like you take some assumptions and then you work out how those assumptions follow. This is
right,
my like
true.
a simplistic version of abstract maths. In chemistry, it's like, oh, you do some experiments or you then you try to follow things. But in physics,
Right,
there was like, even when there was no experiments to do quantum mechanics properly, people thought about quantum mechanics in different ways. And even like, GR was first thought about. And so I think those
yeah,
kinds of things, though this was much, I would say I appreciated this subjects much later on. But whenever
right,
I looked at physics, it was like you could start from very scratch and think of something like and think of a relatable physical example. Like even math, you could start from very scratch. Like you can build your construct
right,
from very
true.
scratch. But there is no easy real world example to see in maths, in my view,
Oh yeah, true.
when you start from
Like physics is
scratch.
very tangible. Like you
Yeah,
can feel stuff. Yeah, like
you
math
can
can be very, very abstract. On the other
exactly.
side, like, you have engineering that is way too tangible. Like you can feel like almost every single thing. So
Yeah,
mostly like physics is a bridge between the two, right? So you
yeah,
wanted something in between.
yeah.
And the
And
thing that really got you into physics was classical mechanics.
yeah, classical mechanics or electrodynamics, I would say. This kinds of like things which you do some problems at on your paper,
Mm.
but there are also relatable examples you see
Mm.
around you. Like when I was doing
Right,
thermodynamics, and like my mother used to boil milk, and I was always used to like imagine how are these equations working while my mom is boiling milk. So I think this was
right,
maybe I was not completely right in connecting things, but at least there were connections which easily came to me.
right.
And
Okay,
the another aspect of physics which I liked, which I later realized I liked in college was more of like some mathematicians don't like this when I say, but let me go ahead and say that maths is really I sometimes feel is a very good language for physics. If I want to
right.
express physics, like if I'm talking to
True.
you, English is a language, right?
Right, true.
But similarly, if I want to convey physics, maths could be a language of of conveying physics. So I liked this extremeness in physics. Like there is like boiling milk is also physics, but then you can
Right,
write very hard differential equation which is like impossible to solve analytically, and that also says
right.
physics. So I think this extreme nature of covering very tangible thing and like extremely abstract thing in one concept is something I found very attractive.
All right. So this was the highlight and takeaway of your bachelor studies, I
Yeah, I
believe.
would say.
Like
Yeah.
eventually, right?
Yeah. So in college was real exposure. Like I was very
Right.
lucky to be at a place where there were a lot of active physicists doing research and also teaching very well. I
Oh
must say,
yeah,
like
right.
excellent teachers I got, and they were very good at tapping your interest, not just exciting your interest, but if you have interest, tapping it and then taking
Right.
it forward. So I was also very lucky in that sense that
Right.
I got this opportunity in Mumbai to study physics. So this was like really like I was really enjoyed my 5 years doing all kinds of physics, including astrophysics.
Okay. And which courses did you enjoy the most? Because we take plenty of these, right? Like plasma
Yeah,
physics,
yeah,
nuclear
yeah,
physics, particle physics. I don't know. I even like, I mean, did the exam for the quantum field theory, I think,
exactly.
when I was a bachelor student. So you can take up on any of the special topics. So
Yeah,
what was the first thing that really blew you away and you really figured out that, okay, you can pursue this field further on and then move forward?
yeah. So so my bachelor, so it was an integrated course, bachelor's and master's. So 5 years at same place, and you do
Okay.
a series of courses exactly as you said, like you do classical mechanics, plasma physics, quantum physics. And
Mm.
I had a very traditional degree, I would say. So I had like classical mechanics 1, 2, 3, quantum mechanics 1, 2, 3,
Okay.
electrodynamics
Right.
1, 2, 3,
Right.
like experimental physics 1, 2, 3. So before
Okay.
taking any of the advanced physics like quantum field theory or solid state physics or astrophysics, I had to do all of this 1, 2, 3, 1, 2, 3, 1, 2, 3 business.
All right.
And
Okay.
they were very interesting. And but in my first year when I was doing basic physics, all of it again, there was a bit of a contrast that in class I was getting introduced to all of these advanced topics like special theory of relativity.
Right.
And then there is this twin paradox where there is one twin which stays on Earth and one twin which goes around, and that comes and there is age difference. And I was like, oh my
Right.
God, what is happening? And then I go to lab and I measure resistance. Like it was so not in sync.
There's a huge contrast between different
Exactly.
subjects, right?
Exactly.
But as you see, like that is like the beauty of physics. Like you can do plenty of stuff. It's never repetitive. And we usually say like unlike astronomy or astrophysics, which is a 1 centimeter ocean, physics is like a deep well, right? You don't have like
Yeah.
that many topics to explore, but it can go very, very deep.
Yeah. So I like that aspect. Like, oh, this is like, again, the extremes played a role. I enjoyed lots of stuff. I mean, I rarely use
Yeah.
quantum mechanics now, but I also enjoyed a lot of quantum mechanics. A lot of this I now feel, I didn't feel it then. I now feel was also driven by teachers I had. So the
Of
quantum
course,
mechanics
yes.
was taught very well.
Physicists are very good teachers. I don't
Yeah.
know if you agree with that. Yeah, right. I mean, I had like plenty of math teachers, but then math really depends. Like you have to be lucky. But people who teach physics, plenty of them can be very good teachers because the topics themselves are really interesting. They're quite niche, and then there are stories. There's a lot of storytelling also from a historical point of view that how we started understanding these dilemmas
Yeah.
and how they grew and then how we're dealing with them today. So like I
Yeah.
mean this is something that is evolving also
Yeah. Yeah. Yeah.
during the time that we are learning this stuff.
Yeah.
So
Yeah.
okay, let's talk about the fact that okay, so you were a physics major, then I imagine that you had a master's again in physics, right?
Yes, the degree was in physics.
And was it more specialized? Was it like general relativity or quantum mechanics or something else? Because we had this like deviation from just physics that you had to choose something.
Yeah, so it was very similar. There were lots of electives, as they called it, so elective subjects.
Right.
So there were few options, and you could choose, and all of them were advanced physics. I did choose GR, then I did choose QFT, quantum field theory,
Okay.
general relativity. So there were
Right.
few advanced courses like the solid state physics, which is the advanced
Right.
version. So I did some of those. Those seem very difficult to me. If I remember now, it was like quantum field theory. I think was extremely difficult. I mean, I don't remember anything, of course, now, but I never
No,
enjoyed
really?
it
You've
back.
forgotten everything.
I never enjoyed it back then. Also, I should say I found
Oh
it
my
very
God.
difficult. Yeah,
Oh, it was one
and
of the best topics I ever passed. And I
wow,
remember like it was the only subject that I scored 20 out of 20. Like it was impossible in that university to like score the complete score, but then
yeah,
I got it all like I mean I really love that. I think it was
good.
I mean they say like it's one of the best intellectual theories ever written by human beings, right?
Sure,
I think
sure.
like
I
by
mean, yeah,
far.
yeah,
So
sure. I also almost found it like a painting I was not able to appreciate. So it was very good. I know that, but then I was not able to appreciate. So
Oh my God.
so I know it is
So,
beautiful, but I was
okay.
not able to
Yeah.
appreciate in totality, like I did some of the other subjects. I mean, quantum mechanics
Okay.
1, 2, 3 was like, I was like, oh, wow, can
Yeah.
humanity, like, can thinking go this far? Was
Right.
clearly evident to me, and I'm pretty sure that is also true for this advanced quantum field theory, but I was not able to appreciate it.
Yeah, right. I mean, it becomes very, very mathematical because at least I would say quantum mechanics, there are some types of topics that you can still connect to, especially with regards to like classical mechanics or like there's a combination of a special relativity coming in with Dirac equations, etc. But yeah, it's a very different topic.
Yeah, yeah.
Um, so I mean, how was your relationship with general relativity then? Because
Uh,
I mean, there like you also have a lot of hardcore mathematics, but it's a very different thing compared to quantum field theory, I have to say.
so yeah, I liked GR quite more than that and then QFT.
Yeah.
And I also like the idea that I was saying you, right? That when I was doing GR, I almost felt, oh, differential geometry is like the language.
All right.
The,
Okay.
the thing I said you had in my 5 years, I appreciated this by multiple channels, and I was hit with this wall by multiple channels. that maths is really language of physics. So if you want to talk physics in an some kind of physics, I'm not saying all kinds of physics. If you want to talk some kinds of physics, you have to learn that language. So I like
Mm-hmm.
this concept in GR where differential geometry was taught initially to us, which is because there's a language of physics. Like you have to
Right.
understand what is curvature and how it is a four-dimensional space and how
Mhm.
things move and uh, uh, what is the trajectory in a curved space-time. I mean, this has nothing to
Right.
do with physics, right? It's a very beautiful mathematical problem which also has theoretical, physical and theoretical
Yeah, right.
implications.
Okay, so the pattern that I'm seeing here is that you're always falling on the side of classical mechanics. Because this is the thing that was like starting, like you started from Newtonian mechanics, then it was again like about studying more of advanced physics and mathematics, etc. But then like you're always like very much into movement of particles, of how things are working, etc. Because for quantum field theory, you also have a lot of mathematics. Like you have the focus space, you have the Hilbert space, you have all of these like tensorial or mathematical matrices that you have to like do operations
Yeah,
with.
yeah,
So
yeah.
there's
I
the
remember.
like
I
language
remember the
also like
horror.
implemented there.
You are reminding me of nightmares. I know this.
But yeah, like what I'm seeing is that like you're really invested in understanding like how things move, like how things float and how things are evolving. Because
Yeah,
what we have in quantum mechanics is like time is always at the background, right? Like you're not really feeling it. It's not about things moving or evolving or whatever. Like you have this type of like wave function collapse, for example, which is a very like if not abstract concept, it's something that has nothing to do with time. Like it's very much like isolated in a sense that how systems or yeah, like it's not much about like how things move, let's say. It's about yeah, how things evolve. It's not about like I mean trajectories or something because I mean you don't have these everyday concepts of like particles moving time like very much like classical mechanics. The quantum
yeah,
mechanics is all about yeah the measurements, the
yeah.
measurements that you're making on a system because you have no correlation with subatomic world somehow.
Yeah, true. Yeah, could be. Yeah, I mean, uh, yeah, it maybe now maybe once you said this, I'm thinking loudly now. Maybe it resonated with the idea of life. One has to move on, even if it is in a
Yeah, right.
curved space time. One has to move.
I mean, yeah, because I mean, again, like general relativity is all about trajectories. I mean, when you're like talking about like Schwarzschild solution or like
Sure,
Kerr interior solution or like I mean stuff like that. I mean, unless like you're moving a little bit forward, which becomes very abstract, like black holes or UNRWA radiation, stuff like that, then
sure,
I think like in that space, like you're very close, like it's still in the regime of like classical mechanics, how things move, but with a great precision.
sure,
Like
sure.
it's
You
so
could
much
say.
precision.
Yeah, yeah,
While over there, like if you're like just opening a quantum box and you're looking at it as an observer, you're just interfering with the system and you make everything freeze, right? Like there is like no connection. Literally everything is just abstract. It's just what
sure.
you're thinking, right?
Yeah, makes sense. Yeah, I understand.
So, okay, so I can say like there is still like this concept of what is too abstract for me. And then like for you, like quantum mechanics is like basically okay, like I appreciate it, but yeah, like it's like one of these like modern paintings that I don't understand, like what is conveying. It's
Yeah,
just whatever it is.
I like to tell a bit more. I love abstract painting, and in my college, I actually used to paint. I've not painted from ages now,
Right,
but I think the subject quantum mechanics, the basic stuff resonated with me. But this quantum field theory, I surely remember I had nightmares because I so wanted to understand it. It was like intent was
right, true.
100% there. But this was also I it's not very ideal because this was like final year of my college and like I was looking
Right.
for PhD positions and there are like my all friends will disperse and the life will change. So there were 300
Okay.
other things going on. When I did QM,
Right,
I was in my first second year. The only thing I worried about was physics. Uh,
right,
but by the fifth year, there were a lot of other things going on which might also have contributed. We try to usually see a student or a researcher by themselves, but there's lots
right.
like in an academic world, but there might be other things going on which might be doing some crosstalk with their
No, of
academic
course,
life.
yes.
So
No,
it,
yeah, like I mean, usually it's the meme. People see us as the meme, right? They
yeah,
stick with the brain on top of it, right?
yeah,
You don't do
yeah,
anything else, like
yeah,
you don't have a background life. It's
yeah,
just you sitting somewhere focused, studying,
yeah.
thinking, and then yeah, a very abstract life, but yeah, no, it's not like that. So yeah, so your journey in astronomy started from general relativity, and then how much is playing a role these days for you? Like, I mean, are you still connected or no? Like you have left all of that behind?
No, so I don't actively work on general theory of relativity now. And in astronomy, to be fair, like in my college, I did summer projects. We had this summer internships, which I did three projects, and all three of them were in astronomy and very different.
Okay.
My first project was on gravitational lensing, and it was radio data. It was completely observational.
All right.
My second project was on dynamos and magnetic fields, the stuff which is still relevant now. And my third project,
Yeah.
which was my master project, was on astroseismology, which was
Okay.
relations in stars. Uh,
Right.
and this three also gave me different aspects. So this is like a tree. Now we are going branching, branching, branching. So from physics
Right.
I branched to astrophysics, but then in astrophysics
Right.
also I branched. And this three gave me a very different view of astrophysics. When I was working with radio astronomy data, it was a part of it was also converting voltages to images.
Right.
Like I
Okay,
was,
so I have a question before we move forward.
sure.
So you started doing summer internships, but not again in physics. Like there was a shift to astronomy, astrophysics already, right? Was it
Yeah.
because those projects were available, or you just like gave up on the idea of pursuing physics? What happened?
No, so the point was like uh, I was so in our department there were a few astronomers and they
Mm.
were teaching physics, basic physics. I was fluid
Right.
dynamics was taught to me by an astronomer.
Mhm. Okay.
And so I would talk to them about fluid dynamics and its connections to
Mhm.
astrophysics. And usually they will have some problems which is a fluid dynamics problem, but for an astrophysics world.
Right.
Like how is the mass flow going on and what is the radiation
Right.
accretion disk and stuff like that. So
True.
when I was talking to them, uh, in my interactions with multiple of my professors, some astronomers, some doing basic physics, I realized astronomy is very interesting because it's like a detective's job. It's like something somewhere very far has happened in its own right, and
Right.
you just get signal from there and you have to figure out what's happening.
Right.
So I
Yes.
found that very intriguing. Something somewhere very far, like it's not very far both
Right.
in space and time. Like it's very far from
Right.
us and
Very
very back
true.
in time.
Also time-wise, yes.
Yeah, time-wise it's very far. Has happened, and you are just getting some signal now, and you have to like decipher the whole story. Like what happened there,
Mhm.
how is this radiation reached Earth, why is this radiation at this wavelength. So I got
Mhm.
intrigued by that aspect. Like, the boiling
Right.
milk doing pendulum thing broke, right? The scale with which I
Right.
started physics really broke. That now you
Right.
can't, it no more remained relatable.
Right. True.
So I wanted to explore this aspect of astrophysics. That's why I started applying for internships in astrophysics. Because course
Mhm.
was fixed. You have to do this many
Right.
steps before you can get an elective in astrophysics.
Right.
But I wanted to explore, and I applied to a few places again. And I
Mhm.
got through one of these places, which is actually GMRT, which is a radio astronomy telescope in India. So
Right.
I did my first astronomy internship there.
And then this time we had nothing related to movements. It was like finally you were like going from classical mechanics to quantum mechanics kind of because it's all about light, right? Astronomy, astrophysics is all about like what is in the signal. Yeah, like it's about how we're interpreting the light, right?
Yeah. So there was a lot of optics because my first project was in lensing, but
Right.
but it only seemed lensing, and I first few weeks I studied what do you say optics,
Mhm.
like how to translate concepts I've learned in optics to gravitational lensing. But then it
Right.
soon became about all of these technical things of there is a correlator and it correlates and there is a time correlation and there is a data
Right.
software package, and so soon it
Right.
became changing voltages to images. That's how my
Right.
first interpretation
True.
was, because the radio telescope is just measuring some
Right.
voltage. You have to do a lot
Right.
of very smart. Like when I still remember the feeling when I learned how they
Hmm.
convert I mean, this is extremely, like, extremely smart way of exploring the universe. So I was very excited about that part.
Yeah. Do you want to talk a little bit about it? That what
Sorry?
was your first exposure to radio astronomy, and then how was
Yeah.
your memory of it around it? Like, is there like a
Yeah.
profound moment that you're still like thinking about these days? Because I mean, these are like very early memories of how you started the field.
Yeah, so I have a bit of memory of that project. It was like there is the basic reading because I came from physics, so I knew nothing about
Right.
gravitation. Right, so there was a
True.
reading time, which was a gala time. I was again at a very new place, Pune, at a very new institute, a institute
Right.
where there are no undergrads because it was a research institute.
Oh, okay, right.
So only
Okay, fine.
summer students are undergrad. There were like eight of us who are summer internship students
Right.
there for 3 months, and like going to all of these places. Like if you talk of memory, I would say I went hiking then, and I went to all of these restaurants to have food with my
Yeah.
friend. So I think those
Yeah,
memories
right.
are also very
And you're
alive,
still doing
active.
those things, right?
Yeah,
As a professional astronomer. There's a
exactly.
continuation to hiking, yeah.
Yeah. So, and I still have a lot of friends from those days. Like we are still in
Right.
touch, and many of
Oh,
them
okay.
actually did become astronomers.
Oh,
Out of
well.
those eight, and I'm in touch with them, a few of them also now. But
Right.
in that moment, it was like I was trying to see how this. And when you go to see a telescope, like radio telescope, because my understand, like if you say my high school understanding of telescope is like watching stars at night, but radio
Right.
telescopes work anytime. Does that make
Yeah.
so?
I mean,
Yeah,
it's still a very precious spiritual type of experience, I think, for
yeah,
everyone. Like our
yeah.
relationship with the night sky is something very special. I think like it's very personal, it's very special. And then
I
people say
agree.
like it's one of the most spiritual practices. Like the way that we're looking at the night sky, and when people, for example, international, I don't know, in ISS, for example, like look down. So like we
Yes.
have an overview effect that we see
Yeah.
things like in a completely different light, right? So
True.
like back
Yeah.
and forth is a very like different thing, but yeah.
I agree.
I mean,
Yeah.
just
Yeah.
wanted to defend the night sky, you know.
Yeah.
Don't
True.
underestimate, yeah. Our
No, no,
naked
I'm
eye
not
are
under.
good telescopes as well.
Sure, sure. I mean, all of this is for sure. I'm nowhere underestimating, but I'm just saying my connection with astrophysics. Usually, people's connection with astrophysics is via night sky, but my connection with
Right,
astrophysics was the physics detective point. That this is the
right.
a
True.
subject where my physics might help me become a detective. So it's killing
Right. True.
two birds with one arrow.
Right. No, true. No,
Uh,
absolutely, yes.
so
Okay,
when
so
I
you visited this radio telescope, and
yeah.
how was the experience? Because they're gigantic, right?
Yeah, there was and there are this dish. This is like dish, and it was an interferometer, so there were multiple dishes. And then they took us to like the correlator room, which was extremely cold because I think they were doing lots of
Right.
calculations and requires a lot of
All
cooling.
right.
And there was a very good prof who was explaining each step very well, and I found it remarkable, like like something which looks like this, and then you look at the image which this guy has given you. There is so much maths, physics, data science, like
Right.
such an amalgamation of like multiple physics. It's not just math.
Right.
It's like electrodynamics helps you get the data, then there is data analysis which you have to do,
All
and then
right.
there's correlation, time correlation. Then once you have the image, you have to invoke some like GR to explain gravitational lensing,
Right.
right? By
True.
how much angle is goes, and that
Right.
helps you determine mass of a galaxy. Like it was like it's like everything. It was like a symphony of physics. Everything came together to
Right.
create this
True.
wonderful
It's the
music.
crossroads for like many different fields, right?
Yeah,
So you should have like plenty of expertise and skills to also fit in, I
yeah,
think.
yeah, exactly. So
So with for someone who had like a very wide background like you, I think that was really intriguing, right?
yes,
Okay,
I
now I can use like every single piece of my knowledge somewhere. So
yeah,
yeah.
exactly. Like lots of these elements, because I studied it as element, like stat make 1, 2, 3, classical make 1, 2, 3, electronics 1, 2, 3, QM 1, 2, 3. Lot of this came together to in astrophysics. That was my first internship experience. Uh,
Okay.
and I gave a talk for first time, and I wrote a report for first time. So I think there were
Okay.
those aspects of it also which I have good memory of. Like I was whole night I was thinking like how could I give this to how could I give this talk to an high school student, because if I've understood when I'll
Yeah,
be
right,
able to explain to high schools. So I have those memories also, and I was very tense before the talk because they will be like, these are all like very senior professors and
right, of
like,
course, right,
oh, just a summer student, but also they were extremely nice. All of them came, asked questions, and so it was exposure in many sense, not just physics. That's what I'm trying.
right. Hmm. No, okay. Right. Are you still doing radio astronomy? Or
Quite a
no,
lot,
like this is like
quite
something.
quite a lot.
Okay.
Yeah,
Okay.
not
So it
lensing.
started from there and you continued with it. Like it actually worked. You didn't have to
Yeah,
move that much.
I went
Okay.
back and forth. Like even the second project I did was at Ayuka, which was also in Pune, but I rode across. The first project was NCRA, which is Center for GMRT, the radio telescope. The second one is Ayuka, which
Right.
was more of a theory numerical simulation project. So I have also aspects of it in my current research. So you could say my first two project, if you combine my first two project and advance it, that will be somewhat of my current research.
Okay. Nice. Okay. Makes sense. So you actually had, okay, let's say like you're coming from a physics major and then for astronomy, it was mostly your summer internship that shaped your
Yeah,
future career, literally.
exactly.
So the foundation was that part.
Yeah,
Okay. And
totally.
how
Like
was
when I,
your,
sorry, go
yes,
ahead.
please go ahead. Now, how was your PhD experience then after this one? Like,
Yeah.
was it something that was very far and beyond your expectation? Or like, did you have any difficulties? Or no, like it was exactly what you expected and it just met all of your like
So
criteria or something like that?
so in my during my so I did these three projects where I got a view of astronomy in different way, and then I thought, oh, I would like to do astronomy longer term. So I
Mhm.
applied to a few places, and I was very so I did my PhD from Newcastle in UK, and
Right.
my supervisor was Anwar Shukurov, and he's like a fantastic supervisor to have. Like
Okay.
again, I there is a scientific aspect of it which I enjoyed talking to him and working
Mhm.
with him and discussing with him a lot. But there's also like a non-science of it. He's such a jovial and a energetic guy, which was
Right.
another kind of experience. When I met him, I was like, he was so warm, and he knew I'm not from UK. I came from India, so he was considerate.
Right.
And we did work on cosmic rays, which was mostly simulations, I would say,
Mhm.
simulations and theory, like very
Right.
hardcore theory and simulations. So doing some equations and then reaching a place where you can no longer solve equation analytically, then you solve it in a computer kind of thing.
Right.
So you
Sure.
make a construct, make a setup using analytical equations, and then you use computer to solve these equations because it's analytically not possible to track. It's not intractable analytically. So, but
Right.
it was like how productive was I is still a question and up in the air. But I had a gala time. Like my PhD was, the place was also very nice. There's like it is.
Right.
The people around were nice. My PhD supervisor was. If I have to do PhD again, which I would certainly not do, but if I have to do it again, I would do it under the same guy. Like
Okay.
if I have to do PhD, if I'm asked to do PhD 10 times, I would ask the same person 10 times.
Oh, well.
Uh, in,
Okay. So it
in
was a huge mentorship experience also for
yeah,
you to learn
yeah,
like how a good supervisor should be.
yeah. I think he really shaped my idea of supervision or mentor and mentee, and this
Right.
mix is he's very, I would say, very very smart, witty, and compassionate person.
Oh,
It's u-
okay.
it's usually difficult to find this combo, right? Either,
Oh, of
right?
course. Yeah, right. It's rare
He's
actually,
very,
I would say.
yeah, it's very
Right?
rare.
I mean, yeah, like
Yeah,
witty, compassionate, and smart, yeah, like all at the same time. Usually there's like one or two missing. Usually.
yeah,
I mean,
yeah.
if you're
I
finding a
agree.
mentor in astronomy, right? Like that's a very rare
Yeah,
case.
yeah, I still
And
talk
he's
to him,
also
and
originally Indian, or was he like,
no, no. So his name is
no,
Anwar
okay.
Shukurov. He's originally Russian, actually, who moved
Oh,
to
wow.
UK.
Okay.
So he did it. So he's
Hmm.
actually Zeldovich student.
Oh,
So
oh,
Anwar
wow.
did his PhD with Zeldovich,
Right,
and
okay.
and Sokolov. These are two Russian in Russia in Moscow, and
Right.
Then he was there for some time, and then he moved to UK with his family. Uh,
Right.
so uh, he's very thorough with his physics and his physics expectation also, because
Of
Russian
course,
school
yes.
after
And
this.
I believe mathematics as well because
Yeah,
Russians are
yeah,
super good at math. So, like I don't know how they do it, but they have this intensive reading and studying of mathematics and a huge love for it. Like, I
yeah,
don't know. I think they're some of the best mathematicians in the world, if I'm not
yeah,
wrong. Like I
yeah,
think they're like the top five, something like
yeah.
that.
And but he was very, yeah. So he is from this Russian school of thought, very strong in physics and maths and astrophysics,
Right.
and but also very interested in observations and simulations, and basically what, like if you go, like he's happy to talk anything you want to talk with him. And at times when I was worried during the end of my PhD for various reasons, and I was talking to him, and like he had this very fun way of saying, "Oh, why are you worried? PhD is tough, but it's not as tough as buying a cow. If you want to buy a cow, you have to have a lot of knowledge of what you feed him." And so he had a very jovial way of like normalizing. It was
Okay.
fantastic.
I don't understand the correlation though, but yeah, right.
It,
I feel like I mean buying a cow doesn't, I don't know, like ruin your life or like make you a failure or whatever. Yeah,
it,
like but you failing your PhD degree actually can. Yeah. It
no,
can mess up with your life like so many ways, right? But yeah,
yeah,
like
yeah.
okay.
I also was talking to him, and he was like, "Oh, don't worry. Usually, only 5 people fail in 5 years, and last year, fifth person has already failed. So you're fine if you defend this."
So yeah, by default, like according to the stats, you're not gonna fail
So
anyways.
statistics is in your favor, if nothing else is.
Yeah, right. True. Yeah, no, of course. I mean,
So
that's heartwarming.
sorry.
That is heartwarming, yes.
Yeah, he had this, as I said, he had very fun way of uplifting me and like
Right.
supporting me, which I really enjoyed. So I think my PhD experience was very enjoyable. Like how productive it is still a question, but it was very enjoyable.
Yeah, right. So you believe like it was the actual motivation for you to start applying for jobs and then getting postdocs, etc., because you thought like, okay, I can continue with this.
Yeah.
Because I
So
mean,
my
this is a big decision. I mean, until you're making, I don't know, you're writing a thesis for your PhD, then I think you're just securing a degree. So I mean, this
yeah,
is like something that is like, I mean, besides your name, and then it is
yeah.
about like prestige, and then like how people perceive you in the future, etc. You're still a student. But when it goes to job market, I believe there are plenty of people who just quit astronomy and astrophysics because they want to have a more stable life,
Mhm.
or they want to, let's say, like enter the adult life somehow, because I mean for
Yeah,
us like we are still like by a huge degree we're still living like college students. We're
I
moving
agree.
all the time, we don't have job security. So it's a very big decision that after
Yeah,
post PhD you're deciding to stay in this very insecure job market that you don't
yeah,
know like what you're doing like next year, and then every year is very different. So,
yeah.
what was your main motivation? I mean, this was a great experience, but then when you started applying for jobs, what was on your mind?
Yeah. So first of all, I should say now I feel now, again, maybe looking back, I wouldn't have felt it at each point in my life. But now I feel I'm like a very privileged person who was able
Right,
to do things which interested him. Like
right,
if I see myself as a third person, I would say Amit Seta is a very privileged person
right.
who when
True.
wanted to do
This is a
physics.
common feeling among so many astronomers,
Yeah.
astrophysicists, and then people around us. Yes.
So when I
Because,
wanted
yes, for example, like if you're financially struggling, this is a very difficult place to be in. I mean, you
I
should have like some assets of your own to move forward. And then I think like we're not speaking a lot about this.
Sure. Yeah, yeah. So yeah. So when I wanted to do physics in my high school, my parents were very supportive. Like, yeah, do physics. And then I wanted to do
Right.
physics in college. My parents were like, yeah, surely. Then we will see. And then I wanted to do astrophysics. Like, yeah, surely, go ahead. And I was like, yeah, do should.
Right.
But
Yeah,
like,
also that is very important. Family support,
yeah,
friends support. Yes,
yeah,
because like so many families are against this because they're worried that you're never gonna land a real job, or maybe you will do it like much later in life. And
yeah,
then how much you're traveling would hugely affect your life. I mean, your
yeah,
viewpoints.
yeah,
And then, yeah, like you can also value-wise deviate from. what was offered to you by the society you were raised in.
Sure,
And then, like
sure.
that can cause a lot of concerns too if you're coming from a more conservative family, for example.
Sure. Yeah. I totally agree. I mean, there's a flip side to it also. Like, I think I've met extremely interesting people while
Right,
part of my doing my work, right? If you call it normal work is doing astrophysics, like I
right.
have met all of you
Yeah,
guys.
of course, like this is not a normal job.
Yeah, yeah.
None of it. Like the research world, yeah, like none of the things that we do is normal. Yes.
Yeah. So I think there is that aspect also. Like I've met very interesting people, and I usually talk when we are talking with when I'm talking with my parents. Also, I say like it's like I meet the exposure is very high. I get to travel to so many places, see so many places. I talk to like a variety of people at variety of levels that like were very interesting. So I think this there is like lot of broadness and lot of generic
Right.
things I see while being in a very specific field.
Right. True.
Right?
And you haven't like shifted subjects that many times from what I know.
Sure.
It's
Yeah.
like
Yeah.
you've been like, yeah, like you've been like doing radio astronomy and you're still like doing radio astronomy and
Sure.
then still like the things about like electromagnetism, galaxies, etc.
Yeah.
Like they're deeply rooted in what you were educated about very early on. So it wasn't like, I mean, hopping on so many topics
True,
and then finding
true.
your own thing.
Yeah,
Right. Like it's like more or less like linear, I would say, like compared
sure.
to like so many other astronomers. So you had a way to move forward towards, I think, like there was a paved path like from the beginning.
Uh,
It didn't have like that many surprises, I think.
yeah, but I mean, this like lot of it is also how I wanted it to be, and lot of it is also a bit coincidental or like, turned out to be
Mm,
this way. To give you an example, because my PhD was, to give you a specific example, because my PhD was more simulations focused and more theory
right,
focused, I wanted to do observations.
right.
And that's why I applied places. Because when you're applying for job, the first requirement is job, right?
All right,
So,
of course, yes.
so, so, so I
Should be
applied.
opening and then we think about how to, yeah, like fit our expertise into that type of
Yeah,
profile, right? Like it happens quite often,
yeah,
actually. Like we
yeah,
usually do not apply for something that has been open for us. Like
yeah.
we're just like thinking like what is applicable from our expertise to this job profile.
Exactly. So I applied to all the jobs, but when I had a choice, Australia was getting like Australia already had, but Australia had this radio telescope, which is Australian SK
Right,
Pathfinder.
right,
And Australia is also co-host of SK, the biggest radio
right.
telescope, telescope. So I thought like if I want to explore observations, I should look at Australia. And then when I came here, I liked the place. And then of course I did first like lot of theory and simulations, right?
Of course,
Because
yes.
I
All
was
right.
like, it's also like what questions come to you, like like usually I don't do like to. I'm not sure how you go ahead and how you frame this, but usually I don't do a project. I never pursue an idea which just comes to me. Idea has to recur many times. So if I get an idea, like if I get an idea, then I was like, nah, not pursuing it. Then after a few weeks, I said, no, I should really do this to do this. Then so if idea keeps coming multiple times, then I do it. Then I
Right.
explore it. This is my way, personal way. So
Yeah.
at the end of my PhD, I had a lot of these recurring ideas which were still in theory and simulations. So I did
Okay.
some theory and simulation, but then I did like a lot of observations and collaborated here with observational pure radio astronomy groups, and I still collaborate and I still do a lot of. I'm part of this collaborations, which are primarily radio astronomy collaborations. So
How
in
much
that,
of this is affected by the publication pressure, though? Because sometimes, like, you also have to deliver, right? And that is a huge concern that if you think like something is not working now, then you just like put it aside and then you go back to it because you have something else on your plate that you can deliver faster. So you just like focus on that one, you deliver, and then you go back to like what was on the table, and then if it is like publishable now or no.
sure. I have not been affected. If I think, uh, yeah. So I have a big list of failed projects for sure.
Right, of course. Yeah, like I mean that is like on everyone's bucket list. Yeah.
Yeah,
We all
there is
have
a
things
big.
that are like in the future happening somehow, right?
Yeah. So, but those projects also have come to me multiple times. Then only I have
Oh,
pursued them.
okay,
Yeah,
right.
and then they
Okay.
have failed. It's like those
Okay.
ideas come to
Right,
me
of course.
multiple times from multiple directions, and then I said, no, I should now try this and try and fail, or like because it's not
Okay.
possible now, or we need a much bigger telescope, or we need a much bigger computer to do this. So there is a like what do you say closure to that project, but
Right.
I'm saying that for starting point at least it has to recur multiple times to me at least. Then only I try to pursue it.
This is
Otherwise
a
you
very
get
interesting topic. Yeah, right. I don't know.
otherwise you get like
No,
you get 200
yeah.
ideas every day, right? You can't do 200. You are
I don't know. I
bombarded.
don't have like 200 ideas, honestly. I
No,
have
no.
five, maybe. And then like between those fives, like I'm basically like, okay, like this is the first thing that I do, this is the second thing that I do, this is the third thing, and then like the fifth thing is like something that I do like I don't know, 3 years from now.
Mm.
Because yeah, I'm still like delivering all these things that are like in the background. And then like as you're moving forward, then they're like, I mean, tasks to do here and
Sure.
there, right? Like
Sure.
you're
Yeah,
also like
yeah,
working for people and then like
yeah.
completing some other papers, like some other
Sure.
places, etc. So
Yeah.
yeah,
Yeah.
I don't know.
But so I feel again to give an example from my specific research. So what happens is
Yeah.
there is lot of turbulence in galaxies, but
Okay.
this creates and this affects magnetic fields, but this creates a very ordered magnetic field.
Okay.
So from turbulence comes order. So from chaos comes order. I think life is also very similar. From all of this chaos, what
I
emerges
think this is like the chaos theory itself, like there is order in
from
chaos.
chaos.
Like this has been
Exactly.
proved, like whatever that is chaotic, like it has to reach an order like
There
at
is
a
some order.
certain point. So like whatever chaotic system that you have, like at a certain point, like it's gonna find order within itself.
Yeah. Yeah.
So
So,
yeah, no, I mean,
but
yeah,
if
like
you,
this is like mathematically proven. I feel like it won a Fields Prize even. Like Cedric
okay,
Vianney, I think was the person who
okay,
won a
yes,
Fields Prize on this.
yeah.
Right,
So I think
no?
when you see this order, you feel like, oh, this is a nice path, but it is
Okay.
product of chaos, even for me.
Right. No,
Maybe
true.
the chaos is
And it
not
never
very
like
evident.
that too, right? Like you have these moments of a storm and then you have order and again
Yeah,
you're like somehow dragged into another storm. I feel like it just
yeah,
like goes like from like I don't know, a state to a state. Like you have like
I agree.
high frequency to like low frequency, etc. Yes,
It's
it's like I mean, yeah, like quality of life, I would say, for everyone,
yeah, it's all
including galaxies.
including galaxies.
For all of us.
So finally, galaxies did become relatable to our life, right? Because that was my point. They are
Oh,
like when
wow.
I did astrophysics, they are not relatable, but they are relatable to us. Like order comes from chaos.
This is crazy.
I'm taking that as
No, but it is,
compliment.
yeah, like I have to admit, yes, this is, yeah, like everything is always like crashing into each other and you have to be patient during
Yeah,
times that things don't go your way.
yeah, which
Yeah,
are
and
more
this is
than
like
other
something that
ones.
happens in all the scales. Yeah, like
Yeah,
time-wise, spatially, yes, like for all the creatures living in this universe, yes. Okay, so I feel like this laid out the ground for the next question that we have because you were also talking a lot about like how you feel and then like, how your mentor used to treat you and then yeah like how was your experience during your summer internships and then the feelings came up a lot I think in these
so,
conversations that
okay.
how you're feeling about the stuff so as an astronomer slash like astrophysicist how do you feel about living this type of life that is not very common as a researcher like not on a day that you're, for example, like you have like a big failure or like you're very stressed out about job
On an average.
applications or like yeah, like something has failed somewhere, like a I don't know, proposal didn't go through or a grant writing like didn't come through. Or not another day that you're like on a high, that you got something published, like your review paper is out and then like you got minor comments, etc. On a very like normal day, how do you feel about astronomy, astrophysics, being an astronomer? How does it feel?
Yeah, I think it is very self-satisfying. Like
Oh,
there is lot of joy and satisfaction.
okay.
On an average, there is certainly a lot of joy and satisfaction. It's again you
Is
take
it
it
the
from
joy of discovery or is it like the joy of understanding?
it's more like joy of understanding. Like,
Okay.
because you're chasing a question, like usually I chase a question for maybe, I don't know, 6 months.
Mm.
There are all kinds of chasing time scales. There are like 6 months to a year time scale, then there are like 5 years time scale.
Right.
So
No,
there is
true. Right.
so there are all of those, but there is also a lot of joy and self-satisfaction, I would say, when I understand something or when I'm thinking on next steps. it's very interesting and it's very challenging and interesting together, I would say, at least for me. That there's lot
Okay.
of that gives lots of joy and self-satisfaction. And
Okay.
there are also concepts from astronomy which I apply to my life other than research, and it helps there also. I can give you a specific example if you want.
Yes, yes. Go
Yeah,
ahead,
because
please.
this is, yeah. So one thing, right, when to give you a specific example on this point, I'm saying is like, suppose if you take a data, suppose you take
Yeah,
it from a telescope, you measure something in whatever telescope, and you take a data, and then you realize there is lot of noise in some band or some
of
wavelength,
course.
and then you throw out that, right?
Yeah.
So so you cut the noise, and I think this is very important in life in general. One should cut the noise. There is a lot of noise around you in all kinds of things. So just cut the just don't worry.
Right, true. Yeah,
Just
right.
don't worry about signal within that noisy wave band. Just throw that. Just throw that band away, and then you will get
Right.
your perfect trend. So I also apply. So I think that so it's more than just my job. I feel that doing astronomy is kind of very full self-fulfilling. And I'm very
You're
privileged.
also learning lessons about how to navigate your life.
Exactly.
So
Exactly.
you're so deeply connected to the field, you know. You're having, okay, this is having some everyday application also to my life. Yeah, like
Yeah.
cut
Yeah.
out the noise. Yeah, like you cannot like react to everything, right? You're
Exactly.
gonna lose a lot of time if you're concentrated on the noise. It's
Yeah.
also important to identify the noise.
True.
What
True.
is noise, right?
But true. But once you have identified the
Noisy
noise,
also.
please don't get attached to the signal in that mess. Throw that out. That's my please don't please
That's
don't
a
get
very
very attached.
masculine view of it too, you know.
Sorry?
I think, yeah, that's a very masculine way of viewing this as well. I think, you know, like I mean,
No,
yeah, like you see the noise, just get rid of it.
I've
Irrelevant.
I've learned this very hard
Yeah,
way. Again, I'm saying, I mean, I've learned this
don't
very
engage.
hard way. To throw the noise because one is always attached to the signal, right? Oh, I wrote
Right.
proposal for 1 year, then I got time, then I observed it,
Yeah.
and oh, now half of my data is RF noise. So you get
Yeah, right.
attached, right? You don't want to throw, but if you
Yeah.
want,
Yeah, like let go. Yeah, learn to let go.
learn to let go.
No. I mean, this is a, I don't know, awesome way of, yeah, like seeing things. I mean, I don't have this type of relationship with astronomy, for example, I myself.
I think then you are that's also good, I would say. Because then you are more relaxed. You can really separate your work and your life, right?
No, I mean, I'm kind of like thinking about astronomy in a way that like how insignificant we are. Like it never fails to remind me that. Because I mean, whatever that we are working with, for example, like, I'm working with very young stars. And then a younger star that I'm working, like the youngest is like 1 million years old. And then the oldest people that we can, how many thousand years we've been here? Like 30,000, like 40,000 that we've been conscious. We're doing this stuff actively. I mean, it is basically nothing. I mean,
True.
like, all this time that we've been here and we've developed all this technology, this sector, it's like 40, 50,000, like
Yeah.
maximum.
Yeah.
Like, we just don't count, you know. So I mean, it is
Sure.
always like, I mean, looking around and say that, okay, this universe is not about us. So nothing matters that much that we like get caught up in,
Yeah. So
if
it's
that
like
makes
in the
sense.
perspective, perspective. You're saying the perspective, your perspective widens.
Right. I think, yeah. I think it also is like kind of sad because whatever that you do, you know, like in the time scale of universe, it will never count that much.
Because you're thinking it should count, right? If you're just happy, you're happy. If it does, even if it
Right,
doesn't
true.
count, right? That's
Yeah,
what
no,
I said.
right. I
Like,
mean, like the impact that the galaxy, for example, has on another galaxy, or like how much life it's creating, like no matter how many books or papers we publish, like it's not gonna be comparable, right? I mean, on a scale or like I don't know. I think like the scale of productivity is very different.
true. Yeah, I think, but I agree. I see your point, but I'm also saying that if you're happy and if you're living a fine life and you are taking care of yourself and people around you, I think that is counting a lot. You are just thinking of when you say count, you are just thinking of a scientific count. I think there are various kinds of counts, right? Like
Right.
when you say whatever I do will never amount to, or will never count on the time scales of universe. But I think you are count. I think we really are. The counting is very biased. I would say in that sense that you are only thinking of scientific counting. There are way in your journey you touch so many things, and what impact you have. I think nobody has a good gauge of that, right?
I don't know. I think like what we have among human beings always remain among human beings. If we don't impact the nature, for example, in destructive ways, that is, I don't know, destroying something around us, then generally speaking, I think whatever that we create is for us. But we don't have a much bigger impact. Like compared to, I don't know, for example, a dust like collapsing under its own gravity and then like creating a world.
Oh, understood. But I think
Like I
what
mean that's a very like different scale of working and contributing to all
sure,
this
but
world that we have understood.
sure, but I think even impacting human life is, I would say, a big thing. Like in my mind, that's like a victory. Like if somebody is able to impact a significant number of people, or even a smaller people in a positive way, I would count that as a huge contribution to humanity, right? It need
Right.
not
No,
be.
I mean, no, I'm not arguing with that. I feel like, yes, among human beings, like that remains. But then us as a species, I think we've been here for a very little time. And the
Sure.
time that we are spending here is like just so short. And then we're just like seeing all this
Yeah.
crazy like going on. And it's something that is like mind blowing. We can understand it, which is like also very crazy, I think.
Yeah.
I mean, there's like no reason why like we're connected to all of the components of this universe in a sense. Like we can predict it, we can understand it, we can predict it, we can talk about its past and future even. So like for example, we know like Andromeda galaxy is going to be clashing with Milky Way at a certain point, right? Like I mean, this is like a crazy prediction if you think about it. Like it's gonna happen in like I don't know, billions of years. But this is something that has nothing to do with the time scales that we are living in. But this type of discovery is still like remains within us. It doesn't have to do anything with any other species or any other, I don't know, creatures, let's say, like I mean exoplanets or like whatever other thing. Like they don't care about this stuff, right? Like we are the only people who are just like, oh yeah, like this thing will happen. We are like predicting this and that,
So
etc.
we are also lucky in that sense, right? We are able to argue things out. We are able to explain things out. I think I would
Yeah,
see I would see this, what you are saying, I would see this as a feature, not as bug. But it felt like you are thinking, you are saying this is like a bug. I think this is a positive
yeah.
thing, right? We are able to explore all of this. We are lucky.
Yeah, I don't know. I'm just like missing the connection between like, oh yeah, like we're gonna be here for another, I don't know how many centuries from now. And then like we're gonna go extinct and then like we're gonna be away with all of our knowledge, I guess.
Yeah, but if you go to watch a movie that's just 3 hours of your life, but if you enjoy those 3 hours, I think that's worth it.
In a lifetime, yeah. I had
In
3 hours. I enjoyed, right?
Yeah, in 3 hours in your lifetime, 3 hours is irrelevant, right? But if you enjoy that movie and if it adds to your overall happiness, nature, like why not? I think I think it's worthwhile contribution. So I won't scale it by just amount of time.
Yeah, no, right. True. But yeah, like no, I actually understand why we're talking about this because like you said, like joy and fulfillment in
Yeah,
astronomy is the thing that I'm feeling. And then like you have built your life around this concept, around astronomy. So like this is the thing that is giving you most of joy that you have
yeah,
experienced in your life, I believe.
yeah,
And this is why
yeah,
like you devoted your life and this
yeah,
lifetime to this field and exploring like something that is very exotic.
yeah.
Doesn't
It
have
requires.
like that many direct applications to human life, but it makes you
Yeah,
very happy. And that's
yeah.
all it
Yeah, yeah, exactly. And yeah, exactly as you said that this is like I'm putting in so much work and effort because in terms of return there is a lot of happiness and self-fulfillment. And like when people do puzzle on a
right.
newspaper or something, it's not to gain anything, right? It's for fun. And I'm one of those privileged ones who is able to do this for his job, right? So I think that's why I said I feel very privileged that I'm able to do this even if
But
it
I
does.
think this is the philosophy of being a human being. just
Sure.
feeling the joy and have fun. I
Sure.
think everyone is just always directed towards this direction to maximize
Sure.
the fun and joy
Sure.
because that is
Yeah.
what it means to be a human being.
Makes
Like
sense.
we don't want to like just live for survival. We want to
Makes
make some sense out of it, but then more than sense, I believe fun is the central part to all of our activities. Like people don't usually go for the big purpose or like unlocking like potential or something. If working out their brain is something that brings them joy and happiness and they have fun with it, I think like that is the drive
true.
eventually.
Yeah, and this is very people dependent, right? Some people might be having joy in doing something else and doing something very laborious and like so it's very people dependent. Somehow it turns out for me it's astronomy.
Right. I mean, some people just enjoy parenting, for example.
Yeah.
Like the
Yeah.
biggest thing in their life is just being a dad, which
Yeah.
is like again like okay, right? I mean, all of
Yeah.
us like find joy in different
Yeah.
stuff.
Yeah, exactly. It might be very different for very different people.
Okay, so I think like the key word here is like how you're feeling as an astronomer is like privileged and very happy.
Happy, self-satisfied.
Yeah, right.
Yeah.
True. Like any other thing that you think you should mention?
It is very intellectually,
Wise,
sorry?
keyboard wise, like do you think like we're missing something here?
Yeah,
Like
it is.
because like this is like very positive. So I mean like this is like one of the most positive keywords that we had for this like second question.
I find it very intellectually enriching.
Right,
Like need not be again, when like there is a productivity side of things, that how
right,
productive you are, and the system wants you to, there are some parameters where you have to perform. Of course, this is all
right,
part and parcel of work. Like I don't really separate this, to be fair. But I think
right,
it's also like it's very intellectually enriching, uh,
right.
because it's a like
It makes you think a lot.
it makes you think a lot, and then it is. Yeah, it's like, yeah, in sometimes like in my personal life also I'm thinking, and then like my wife is like, oh, this is like professional hazard. because because
Why the? That's such a weird terminology. Professional hazard.
because I have
In what
so
sense?
no, because it's so much like in everything I'm thinking too much, and some things
Right.
actually don't require you to think too much. Sometimes you don't have to
Right.
think too
No,
much,
of course, right.
but
At
it
a certain point, I feel like whatever thing that you have, which is mind-wise laborious, at a certain point, like it just becomes automatic, right?
yeah,
Like you just have certain things to follow, like manuals, etc.
exactly.
Astronomy is never like that. Like
Yeah,
every 2, 3 years, I think the field like goes through some type of revolution, like
yes,
either like language-wise or technology-wise or like
yeah,
field-wise, like in general, like how we do science, like especially now that we have AI emerging technologies. We are
yes,
really doing like transition every single like let's say 3 to 5 years. So it's never the same. And you
yeah.
have to adopt a lot, I guess.
Yeah, but that's the fun part, right? Like always learning.
Right. For us, I think yes. Like we never get tired of learning. We are always students.
Yeah,
Like
yeah,
everyone wants to become like permanent staff like in the future, but I think the actual joy of staying in this field is that you never grow up. You're always
yeah,
a student. You're always in classroom.
yeah. When I went for my PhD, this was my point. I wanted to make sure I learn how to learn.
Right.
Be-
That's
The,
very
I,
important.
yeah, I think that was the time when I realized like I should learn how to learn, because I have to keep learning
Right.
throughout, right? Some new science is happening, some new technologies are coming. I mean, you mentioned AI and ML. I mean, this is taking over all possible subjects and all possible spheres of life, not just astronomy.
Right.
So it's much wider. But if it affects if your specific field, you have to get at least adapted to it or used to it, or like at least learn it, right?
Right, true. I mean, I remember we had a teacher and he was a very good teacher. Still, he was like, there is no good way that I can teach you stuff. You should just start learning it.
Yeah, I
Yeah.
think yeah. I mean, and like it's the nature of the field, right? Like something new comes
Right,
up,
true.
something new telescopes come. It's part of the job, so it's not like you have to do
It's
this,
like
but
you
that
become
also,
part of the system, like
yeah,
learning process is how you integrate with all of these subjects.
exactly,
It's not
exactly.
like, for example, like law or I don't know, biology or other fields that you just go there, memorize the stuff, and you have to repeat it time and time again.
Yeah,
It's like
yeah,
something analytically, like you have to be in that space, something like that.
yeah, yeah.
Okay, so I think the last question, how do you envision yourself in the future in this field? I mean,
So,
not how you're like planning for this, or I don't know, like what are your wishes? What is the mental image that you have of yourself in the future?
keep doing what I'm doing and more of it.
Oh, yeah.
Because
Okay, okay,
because I do research
right.
where I write codes or look at data, write papers. Then I'm very active. I very actively talk to students. Like I supervise students
Okay.
at all levels, like PhDs, masters, undergraduate, and on again both observational sides of things and theory sides of things. And then I do some teaching, very little
Mhm.
teaching, like few weeks a year per
Okay.
semester. Uh, and then I do some what we call here as service. It's like getting involved in committee work and management and
Oh, okay, right. Sure.
stuff like that. So, and I enjoy all aspects of all those four things. So I would just like to keep doing what I'm doing.
So you're already in your future. There's not a next
Uh,
step. Like you're already in your ideal job.
yeah,
You just you want to do it permanently.
yeah, so basically, like to get a permanent job where I can keep doing all of this stuff. I don't mind
Right.
like the point is if I because it's so driven by questions rather than
Mhm.
answers or
Right,
demands.
of
So
course,
driven
yes.
by questions. So if questions change, then I would change accordingly. But the big sphere is still research, supervision, teaching, and service. Like now,
Of course, yes.
what exactly I do in research will depend on the question of interest and what is the available resources. Like sometimes you get a question, and then I do a small
Right.
computation and realize, oh, of course, this will require telescope which is size of three planets.
Right.
So
So
it's
I would
not
say,
possible.
yeah, like so the ingredients and components are there. Like overall, like what you're like envisioning
Yeah,
your future job will be is like very something very similar to what you
yeah,
already do.
exactly. So what I'm
Like
already
there's not a
working.
huge next step.
Yeah, in my view, there's not a, like I would like to move to a more permanent job, like because now I'm in a
Right.
fellowship. So I'd like to move to permanent job. But in terms of work, if you're asking, it's is
It's the
exactly what
same
I'm already
thing.
doing.
Okay. This is real nice. Yeah, like very straightforward. Yeah, like, nice way of putting it. Yeah, like it's exactly what I'm doing these days. Yeah. Not much more change.
Yeah.
Okay, I think we talked about a lot of topics, but if you think we still have something that we have missed out on, or is there like a closing message that you have for someone who's like listening?
Yeah. So I have 2 points. One of them, which I've already covered, is please cut the noise.
Yeah, right.
If
I
you
think this was
want,
one of the highlights of this conversation. Yes. I think that's
if
very important. Yes.
if you really want to see trend in your data, before fitting the curve, you have to cut the noise. So in your life also, before starting, if you have to cut the noise, and then you can find a trend, and in your trend, try to see what gives you happiness and self satisfaction, and however you define it is defined is a very personal definition of all of these things. But I'm saying this are,
Right.
I would suggest, I would like encourage if younger physicists or astronomers are thinking something along these lines to have a career in academia. I would encourage to this because there are a lot of hard stuff also, right? As you were saying
Right.
initially, that you have to move a lot and it's not really a
Right.
fixed place and things keep changing. You're traveling, you don't have a normal job. So there are lots of things which are trying to bring you down in some sense or which are not that great
Right.
in some sense. So what is great has to be really be preferred. So if you prefer,
Of course.
if you get joy and self-fulfillment, or if you get happiness out of this, then all of the rest will be worthwhile.
So you think this was worth it?
It is worthwhile. Yeah, I think this is totally worthwhile for me at least.
Yeah, I think like this is the biggest message of this conversation.
Yeah.
Yes. We wanted to get here.
Yes.
That, yeah, despite all these hardships, do you think it's worth it?
It is
So
worthwhile.
it
Yeah.
was always worth it.
Yeah, so in the moment you might not feel, again, I'm saying, but like
Right,
in shorter time scales, you'll be stressed because as we were discussing, right? The grant didn't come through, or the proposal
right,
didn't get through, or didn't get a job of interest. So in short time, of course, there is, but that is nature of life also. And if you look at short times, you'll always be either very happy or very sad. You have to
right.
increase your time when you
Yeah, no,
average
right.
over multiple realizations. That's
But
the
really,
thing.
life is not about averaging out all of our experiences, right? It's about
Yeah.
really going through all these details. And then, like, I think yeah, like, we're actually pursuing this short-time happiness stuff because happiness never lasts. And I don't think, like, anyone is going after a lasting happiness.
Sure, no, but I mean to take a decision, you should look at the average. You can't. My point is like, of course, these are
Yeah.
experiences. That's my personal view. Experiences are very short time, like short time scale, like very happy, very sad, very happy, very sad. But
Right,
to take a decision whether I want to pursue this career or not, or whether I want to be in academia or not, should be like an average. You should take an average. You should not
Mm.
pursue academia because one grant got successful. Or if you should not
Okay,
pursue
yeah.
you should not leave academia if one grant got unsuccessful. My point is that
Right,
the decision should be at you take average of everything, and then if you're happy, if you're above the line, then you should go
right.
with it. That's my point I'm trying to say.
Oh, okay. No, this is clear. Nice. No, yeah, right. Okay, so thank you so much. This was a great conversation.
Thank you. Thanks a
Very
lot.
much appreciated. Thank you so much.
Thanks a lot. Thanks.